In this video, we're going to take a look at electrical discharge and some real world examples. So, by the end of this video, you're going to be able to describe what electrical discharge is and explain why it occurs. And you're also going to be able to explain how lightning, a really great example of electrical discharge, occurs. So, let's just get right into it. Now, we first need to start with a definition of electrical discharge. A really great example is if you've ever been shocked by a door handle after dragging your feet on a carpet. So, why does this happen? Well, electrons will be held in an object and they're just going to be waiting to get out at the first opportunity that they get. So, for example, if you drag your feet on the carpet, you're actually building up electrons in your skin. And then when you touch an object or actually even come near to an object like a steel door handle, those electrons are going to want to escape and going to want to travel to that door handle. And so that transfer of electrons is that zap that you feel. So, once an object becomes charged, it's going to remain charged until it touches or comes close to another object. And that sudden flow of electrons from one object to another is what we call electrical discharge. So, in terms of examples, like the door handle in your hand is a great example. But one of the best and biggest examples of electrical discharge is lightning. So, what happens over time in clouds is that electrons are going to build up in the air over time to a point where the sky can't hold them anymore. And so lightning is a discharge that's happening, and those electrons are moving from the cloud to, depending on the type of lightning, it can either you can either get a discharge within the cloud between the negative base and the positive top. So that's lightning within a cloud. You can get it between clouds, so it's going from the negative and positive areas of two clouds, but most of the time, it's a discharge from the negative base of the cloud to the positive ground below it. So coming down from the cloud to the ground. It's not necessarily always the ground, too. Like lightning is going to strike the nearest conductor to get to the ground. So lightning's going to find anything that's made of a conductive metal or anything damp or wet. That includes you if you are out in the rain in a lightning storm. Um, the odds are getting struck by lightning is, 1 in 15,000, maybe once in a lifetime, not even that. So I wouldn't worry about it too much, but you do want to take precautions when there is lightning around because you do not want that to be you. Now, um, a lot of buildings to protect themselves attach lightning rods. So these are metal rods that are attached to a wire that's connected to the ground. So they'll put the metal rod up here, and then the green coming down is a wire down to the ground, and usually they use what they call a ground rod. They place it high in the sky, so lightning is going to strike it, because that will be the tallest thing in the sky. And so by having these, it actually prevents people from getting struck by lightning. Because if it's put high up in the air, the lightning's going to strike it rather than the people. There are some buildings themselves that act as lightning rods, like the CN Tower is a really great example. So that is what electrical discharge is, as well as some real world examples. That's it for this video. Let's move on to our next task.